Thank you for joining me for another lesson here in Math 8. This is Unit 4, Lesson 5, and we are solving any linear equation. Our goal today is just solve some more equations. We're going to get a little more practice in what we've been working on lately, and I'm going to emphasize a lot of the same things that we've been talking about over the last couple days, and I hope that it makes a little more sense as we get going through it. First thing we have here, four problems that right off the gate, they look pretty darn easy, but let's talk about a couple of my favorite mistakes that happen here. The first one, our goal is to get x all by itself. And so the first thing we would do is look at that and say, okay, if I subtract 5 right here and 5 right here, and then that eliminates the 5 from both expressions, and then I have x equals 3. Remember that I have this new strategy that we talked about yesterday, or excuse me, in lesson 4, where I can verify if my answer is correct. So I always want to double check that. Now see what happens is when I plug that back in and substitute it, that says 5 minus 3 is 8, and we know that that's not true. My favorite mistake that happens in problems like this one is with that lovely little minus sign. It's often forgotten, and because it's often forgotten, we get the wrong number in there, but we won't know it's the wrong number unless if we actually check to see if our answer works, if our solution makes the equation true. By bringing that negative sign down here, I'm saying that I want the opposite value of x to be 3. And the opposite value of my number as a positive 3 would be a negative 3. So how do I actually avoid getting that wrong answer in the future? There's a couple of ways to do that. One way to do that, if you see an x sitting here all by itself or any other value that's a term with a minus of the variable, we could actually go like this. And we could say, 5 minus a number is equal to 8. If I wanted to just simply add that x to both expressions, I would eliminate that x from the expression on the right, moving it to the expression on the left in its opposite form. So that would be 5 is equal to 8 plus that unknown number. And this may be something that could help us out a little bit differently. And then we can approach the problem from a different method, eliminate the 8 from both expressions, and then I find out 5 minus 8 is a minus 3 is equal to x. A little bit different approach, but we get the exact same outcome. One other possibility that we can do with this, there are lots of them, but another idea that I have, and I've done this enough times that this is a strategy that often helps me, is if I know that that one is going to be a negative number or the opposite of what it is, perhaps I just want to change the entire equation for that. I want to make this its opposite form and make it a positive x. To do that, I would have to multiply by negative 1. But if I'm going to multiply this term by negative 1, I have to multiply this term by negative 1 and this term by negative 1. So I would say the entire equation, both expressions, would get multiplied by negative 1. It would be more appropriate for me on this side to go like this. And what that would do is give me a minus 5 plus x is equal to a minus 8. Add the 5 to eliminate it from the expression on the left. Notice that the x is a positive x in this case. Add the 5 to the negative 8, and I find out x is equal to negative 3. Now, 3 different ways that I've done this, but all 3 ways when you think about that and we substitute our value back in for it, when I take 5 and I subtract negative 3, I get positive 8, which is a true statement. And that tells me that my value for x is definitely negative 3. The rest of these should go a little quicker than that, but that was one I wanted to put out there because, like I said, there's a lot of mistakes that happen in those situations. Number 2, we want to eliminate this constant of minus 2 to get the x all by itself. We would add 2 to the expression on the right, add 2 to the expression on the left to maintain equality in the equation. Eliminating there, leaving us with an x, and a minus 1 or a negative 1 plus 2 is equal to positive 1. Just very quickly verify that I'm right. 1 minus 2 does in fact equal negative 1. So I know that my equation, my solution of x equals 1 is in fact the right answer. The next one, number 3, I like this one because it's a pretty quick and easy step. We have -3 times some unknown number is equal to +9. We know that division is what is our opposite of multiplication. If we divide by this coefficient of -3, we always divide by itself so that we can make that coefficient equal to 1. Divide by -3 in the other expression for the division property of equality, and x is equal to a -3. And I know that -3 times -3 is in fact equal to +9. Number 4, the final one that we have, we want to divide by a -5 here, and a -5 on the left expression, giving us a +2 is equal to x. And I know that -10 is equal to -5 times +2. So all of those, we checked them out, made sure that they were correct. There's no need to know if I got the right answer or not, because I know how to check to verify if it's right. This next one, trading moves. I don't have the 4 cards to give you, but I really do want you to pull out a piece of paper and take these down as notes. We're going to work on a couple of these problems. The goal was to be able to give you the option to start wherever you want with it. So I'm going to show you a couple different ways for how you can start. I'm not going to do all of the ways, but I do want to give you some options to be able to follow it. So this is going to be letter A, option number 1. Keep in mind, my goal is to get x all by itself. Right now, I see a couple of different terms. This is a term. Also, the -7 and the -2 are terms. And I need to get those together. So I have some options. I can either add the 6x to this side because I want to eliminate making it 0, since this is a -6x, the opposite of +6x. Or I can subtract the 4x, but sometimes that gets a little goofy because I forget that subtracting another number or subtracting a negative, sometimes I forget how that process goes. So for me, when I see a positive term or a positive coefficient of a term and a negative coefficient, I want to actually use the negative coefficient. I'll eliminate that one first, because that one for me, if I can eliminate the negative, I usually have a better outcome with my work. I usually make fewer mistakes. This simplifies to 10 times x, bring down the -2. Don't forget though, that minus sign travels with the 7, so bring it down with it, the -7. And you see then we're down to a fairly simple step. We can add 2 to the expression on the right for the addition property of equality, which means I have to add 2 to the other expression on the left. -7 plus 2 is equal to a -5. It's equal to 10 times x. Our division property of equality tells us to divide by the coefficient on both sides. And my next favorite mistake, this says -5 divided by 10. Quite commonly, folks will put 2 and say that's the value for x. Here's our problem. Watch this when we check it. -6 times 2 minus 7 is equal to 4 times 2 minus 2. Now, maybe you've already caught my mistake on here and why this is a problem, but I'm telling you that this is how I know for a fact that I have the wrong answer. -12 minus 7 is -19. Okay. 4 times 2 is 8. 8 minus 2 is 6. And I know that -19 is not equal to 6. Therefore, my solution that I thought it was 2 can't be correct because it does not make my original equation true. So I have to know that I made a mistake here. So I want to go back and look at my work again. Don't erase everything. That's just silly. Look back at your work and identify, where did I make my mistake? Okay, I took the opposite here, so on and so forth. And I get down here and I go, oh, wait a minute. -5 divided by 10 is actually a negative outcome. Some of you are probably thinking, oh, it's -2. No, it's not. It's actually going to be -1/2. Now, the cool part about this is I don't have a lot that I have to change. I just need to take out these spots where I put in the correct answer of a -1/2 and a -1/2. half. And then I have a few things that will change. Not a lot, just a few. So don't go erasing everything, just the stuff you need to. So half of 4 is 2, but since we're doing a positive times a negative, that would be a negative 2. Half of 6 is 3, and a negative divided or times a negative is a positive. 3 minus 7 is a negative 4. Negative 2 minus 2 is also a negative 4. And I know that because this is true, this negative 1/2 is the correct solution. Now, let's say that you don't like to start with the term that has the variable in it. Maybe you like to make the term go just to the left. Okay, you can do that. We can say, well, I want to get rid of the 7 first. You can do that too. And we do that using the addition property of equality, leaving with a minus 6 times x on the left, 4 times x plus 5 on the right. And then I will subtract the 4 times x to eliminate this term right here, subtracting the 4 times x over here, which brings me to another one of my favorite mistakes that sometimes we forget. Well, what happens when I take a negative minus more? That makes positive, or is it a negative is a positive, or is it, we sometimes confuse ourselves. So if we need to, remember that subtraction is the same thing as adding the opposite. And when we add the opposite, I can just simply say, oh, if I have a negative 6x and I increase it by 4 more negatives, that's going to take me farther from 0, making it a minus 10x is equal to 5. I want to divide by negative 10 to make it a positive 1 times x. I want to divide by negative 10 here for the multiplication property of equality. And now I'm at 5 divided by negative 10 gives me a fraction. 5/10 is 1/2. But since it's a positive divided by negative, we have negative 1/2. And we already know that that answer works. All right, that was option 2. Again, there are lots of other ways that we could do this, but I want to move on. Letter B. This one. Oh my goodness, I see a fraction at the beginning. That's not very much fun, is it? So what should I do? Well, my first option, what I like to do, is I want to just focus on that fraction. Is how could I eliminate that fraction? And how can I do it equally? Well, in this case, in other ones, let's come back to that one. Let's look at letter D first. And we'll look at these ones kind of concurrently. In letter D, I have a 2 right here. That means literally like this right here, the 2 times x plus 7. 2 times x plus 7 means x plus 7 plus x plus 7. It means I have 2 of these groupings, which means that I have x plus x and 7 plus 7, which means that I would multiply just the 2 out here times each of the terms on the inside. That's one way that I can do it. I could go 2 times x plus, this is positive, so plus 2 times 7. To distribute these values, you might see a teacher draw a line that says 2 times x and 2 times 7. I want you to know that those arrows mean multiply because we're talking about grouping those pieces. So we get 2 times x plus 14 is equal to a minus 4x plus 14. The next step, as we talked about before, we can go in just about any order. We have 4 numbers here or 4 terms here, which means we have 4 different directions we can go. We could add 4 times x here. This is my preferred method. 4 times x here to be able to eliminate that term. And that gives me 6 times x plus 14 is equal to 14. And then I eliminate the constant value, subtract 14 from the expression here on the left and the 14 from the expression on the right, leaving me with 6x is equal to, maybe I made a mistake. What I'm not going to do is quit and erase it all. I'm going to finish this out to see if I'm not wrong. I'm going to divide by 6. Divide by 6, being a little nervous. I know that 0 divided by anything is 0. And now what I want to do is I want to go back here and plug stuff in. Okay, here we go. If x is 0, That means that we have twice the value of 0 plus 7 is equal to -4. Oh, sorry, you can't see that. Times 0 plus 14. 0 plus 7 is 7, so that's 2 times 7 is equal to 0 plus 14. 2 times 7 is 14. 0 plus 14 is 14. Oh man, and since that expression on the left, when I simplify the expression on the left using 0 as the x and 0 as the x on the right, it comes out true. I know that x is equal to 0, and that makes me feel so good because I was worried that that one was going to be wrong. So how could I approach that a little differently? Well, I could instead do the opposite of what I just did. And here, I went ahead and multiplied. But because this 2 is separate from this group, I know that I could also divide off that 2 by 2, making this 1 times the group x plus 7, and that would get me to just single x plus 7. If I do that, though, I have to divide the expression on the right by 2, and what that means is that I'm taking -4 times x divided in half and 14 divided in half, which gives me the equation x plus 7 is equal to -2 times x plus 7. And then I can simply take my steps from here to do the exact same work that I did. Addition property of equality, and I get 3 times x plus 7 is equal to 7. Subtract the 7 from both expressions to give me 3 times x is equal to 0. Dividing by 0 on both expressions, x is equal to, dividing by 3 on both expressions, x is equal to 0, and we know that that's true. Now, let's go back to our fraction. Fractions are a little bit scary, but understanding that concept that I don't have to follow just this step, I do have more than that as an option where I can either distribute straight out by multiplying or I can divide that term off, tells me that I can do something similar here. I can work with that reciprocal to be able to get that back to a whole number. With this value, if I multiply times 2 over here, or 2 over 1, I know that 2 times 1/2 is 1, so that makes that 7 times x minus 6, which is just simply 7 times x minus 6. By multiplying by 2 on this side, I have to remember to multiply by 2 on this side as well, making this twice the value of 6x plus twice the value of minus 10, which means that I have 12 times x minus 20. And then I can go ahead and solve however I need to. For this case, I'm going to take the 7 times x from here and from here, because I don't want to end up with a negative coefficient of x. And then from here, I will add the 20 to the 6. And I'm left with 14 is equal to 5 times x. Division property of equality tells me to divide by 5 on both sides. And then from here, I find out that x is equal to 14/5. And before I start to panic, remember that I can verify if my equation is correct. The cool thing about this, I don't want to automatically go to decimals because fractions are good. We're going to come back to this in a little while, but for right now, I will let you go ahead and do this. X does come out exactly equal to 2 8/10 here. And so we can use 2 8/10 back into our equation to verify if we really have the right solution. For the sake of time, I'm going to go ahead and use a calculator. I'm going to go 7 times 2 8/10. Let me write this out so you can see what I'm doing. This is a 1/2 times 7 times 2 8/10 minus 6. And then I'll go 6 times 2 8/10 minus 10. This is my check section. Okay, So times 2 8/10 is equal to 19 6/10. I subtract the 6, but now I have to do the 1 times 1/2. So I'm going to go times, I'm going to use 5/10. So I get 6 8/10. Now, 6 times 2 8/10. I'm going to go ahead and work on this side now to simplify. Is equal to 16 8/10, and I subtract the 10. Ooh, and I get 6 8/10. I'm happy about that because that means that my expressions, when x equals 2x, my two expressions do equal each other, which means this expression equal the same thing, telling me that x really is 14/5. Even though I changed it to a decimal, even though I did a couple of other little things in there, I'm still using the exact same values to do this, okay? There's a lot of ways to approach it. Let's say that I don't have distributive property and I have one like this. Well, I just learned that I can go ahead and multiply by that reciprocal. So if I multiply this term by 2, I also have to multiply this term by 2 and this one, all of them individually. So I'm going to say, you know what? I'm going to multiply the entire equation to make every single term in here twice as big. 2 times 1/2 is just 1. So I get 1x here. 2 times 7 is 14. 2 times x is 2 times x, and 2 times 13 is 26. And you can see that this equation now no longer has fractions, and I can go ahead and go about it like I would do my normal business. Subtract 1x from both sides. Whoops, that one's not 0, silly. That's just another 1x is equal to, that one's 0 though. 14 is equal to a number plus 26. Subtract 26 from the expression on the left. 14 minus 26 is negative 12 is x. And then I need to verify that that is really true. So 1/2 times negative 12 plus 7. And I'm questioning, is this equal to negative 12 plus 13? Well, half of negative 12 is negative 6 plus negative 7, which is which is equal to positive 1. And negative 12 plus 13 is going to equal to also positive 1. I have verified that x equals negative 12 is the correct solution. All right, I think that's enough of that. If you want to see other ways to do it, let me know. Send me an email or something that says, hey, can you solve this one? Or I solved it this way. Let me know if it works. The biggest, most important thing, though, is verify your solution before you finish what you're doing to make sure that you have the right answer. Don't just assume that it's wrong because, oh no, I got a 0, or oh no, I got a fraction. Don't assume that it's wrong. Assume you're right, verify it first, and see if you got the right answer. Okay, the last thing that we're working on this one, a puzzling puzzle. Tyler says he invented a number puzzle. He asked Claire to pick a number and then asked her to do the following. Triple the number. So here's his number. Let's say his number is x. He's going to say triple the number, then subtract 7, then double the result. So this is going to have to, the result of that has to be doubled, and then subtract 22, and then divide by 6. You could put divide by 6 over here, but that would be divide all this other stuff by 6. And Claire says she now has negative 3 as the solution. Okay, that might look a little bit scary to you, but that's okay. Let's get rid of this fraction part first. Let's go ahead and multiply by 6 over here on this side and on this side. Remember, multiplying by 6 is the opposite. That's 6 over 1. By multiplying by 6, we actually have eliminated that denominator. And we've ended up with twice the value of 3 times x minus 7 minus 22 is equal to a minus 18. So knowing that right there, that just kind of gets us started. Remember, Tyler says her original number must have been 3. How did Tyler know that? Explain or show your reasoning. Be prepared to share your reasoning with the class. I'm going to leave this one to you at that point to see what happens. Try and figure out where Claire made the mistake to get negative 3. And I think I got a little bit of extra credit for the kids that do that. That's everything for today. Remember, when we have an equation with one variable, there are a lot of different ways to solve it. The big thing that we really want to focus on is knowing that a variable equals some number. It's an unknown quantity. At the end of it, once we've solved everything, we know that we can verify to see if we have the right answer. Do not be afraid of a fraction for an answer. And remember, fractions don't have to turn into a decimal to be able to be the right answer. We can simply leave them. This is okay. I know it's called an improper fraction, but it's still a fraction that's actually going to be a much better fraction than saying t is equal to 2.3, because it's not equal to 2 3/10. It's actually equal to 2 3/10 repeated, which is really hard to put back into a calculator. So, excuse me, 2 6/10. I just messed that up. No, it isn't. I'm right the first time. Sounds like it's time for this video to be over. Thanks for working so hard. Go ahead and read through all of this. It's a lot of information that goes back through everything that we did, especially reviewing this distributive property. You're doing fantastic. Don't you dare give up. We'll see you next time.